Alright guys, y'all are being recorded. Let's be on your best behavior. The only reason why I'm making a video is because I never recorded one of this lesson, and I still have kids who are struggling with it and a couple of kids who were absent. So we're just going to do a real quick review of how to simplify radicals. What you're doing is searching for that perfect square, any perfect square factors that are hiding in there, because you want to take the square root of them if you can. Okay, and one way to find all the perfect squares is to break it down into its prime factors. So for 20, what's the smallest prime number I can divide 20 by? 2. 2 goes into 20 10 times. Keep dividing by 2 as long as you can, and as long as it's even, you can still divide by 2. 2 goes into 10 5 times. 5 is a prime number, so I'm done. 5 goes into 5 one time. So the factors of 20 are 2 times 2 times 5. Now every pair makes a perfect square. So there was only one perfect square hiding in here. What is it? 4. Every pair of factors that are exactly the same make a perfect square. So I'm going to rewrite 20 as the square root of 4 times 5. This was the number I was looking for, the 4. The perfect square is what I was looking for. So I can take the square root of it and take it out of that square root symbol. What is the square root of 4? 2. So it comes out, and now what's out in front is a 2. What stays in? The 5. Now, one way to check yourself, this isn't 100% guarantee that you did it right, because you might have accidentally left some perfect square factors. You got to make sure you get them all out. I know we did get them all out because 5 doesn't have any perfect square factors left. But here's one way to check yourself. Take the square root of 20 and see what that equals. And then take your answer, 2 times the square root of 5, and work that out. 2 times the square root of 5, you should get the same amount. So when you have access to your calculators, which we're going to get them out more and more frequently, you could always check these. When we do a daily grade on this, I will let you have a calculator. Okay, 24. Let's break down 24. Are any of you guys doing the factor tree method, or are you doing my way? Okay, so I would always start with the smallest number that I know goes into 24. If it's even, you can always divide by 2, right? 2 goes into 24 12 times. 2 goes into 12 6 times. 2 goes into 6 3 times. And 3's prime. 3 goes into 3 once. Did we find any perfect squares in there? Yeah, every pair that are the same make a perfect square. There was only one perfect square in here. What is it? 4. Multiply everything else back. What does 24 break down to? 4 times 6. Okay, so everything that was left, I just remultiply it back. 2 times 3 times 1 is 6. The only number I was concerned about was the perfect square I was looking for, which is 4. And what is the square root of 4? 2. So we take the square root of 4 then. We actually perform that operation, and the square root of 4 is 2. So now it's freed from under the symbol. It's out in front. And what was left in there? 6. Okay, now 72 is a little bit different because 72 has more than one perfect square hiding in there. What's the smallest prime I can divide 72 by? 2. 2 goes into 72 36 times. Now, if you really know what you're doing here, and you really understand that we're looking for the biggest perfect square we can find, you could really stop right here. Do you see why? Yeah, 36 is a perfect square. You should be familiar with your perfect squares. 4, 9, 16, 25, 36, 49, 64. So hopefully, if you know what you're doing, you could realize, hey, 72 becomes 36 times 2. That's got to be the biggest perfect square that's in there. And it is. Now let's say you didn't recognize that. That's fine too. Let's just keep going. 36 is still even. Divide by 2 and you get 18. 18 is still even. Divide by 2 and you get 9. 9 can now be divided by 3, and 3 goes into 9 3 times. Okay, so 72 breaks down to 2 times 2 times 2 times 3 times 3. Every pair that's exactly the same makes a perfect square. So I really had two perfect squares in here. I had a 2 times 2, which is 4. And I had a 3 times 3, which is 9. So 72 can be rewritten as 4 times 9 times anything that was left. What's left? 2. Now, you can do it one of two ways. Some kids don't like to put the 4 and the 9 back together. You could take the square root of 4 separately and the square root of 9 separately. Or you could put your two perfect squares together and make an even bigger perfect square. What is 4 times 9? 36. 36 was the biggest perfect square hiding in there. And what is the square root of 36? 6. So it comes out as a 6. That lonely 2 that didn't have anything else with it, it has to stay in there. Same thing would have happened if I had brought out the 2 separately and then brought out the 3 separately. 3 times 2 would still be 6, and there would still be a 2 left inside. So you can either take the square roots of each perfect square separately and multiply everything that comes out, or you can multiply your perfect squares together and get the biggest perfect square that's in there, and then take that biggest perfect square's square root. Are y'all remembering this? Because I really wanted to do a daily grade on this, but so many kids are out with the Spanish test, we'll probably do it tomorrow. Okay, now 20. Let's go back to number 1 before I look at number 4. The square root of 20. We figured out that 20 breaks down to 4 times 5, and that the square root of 20 becomes 2 times the square root of 5. Okay, that was number 1. How would that change if number 1 looked different? How about if number 1 had started out like this? 5 times the square root of 20. If this was the original problem. Exactly. If there's a number out here, it tends to confuse kids. Just hold on to that number. Work it out like normal. A 2 came out. Well, there was already a 5 out there. So you would just multiply them together to get the new number that's out front. That's all that's going to change if there's a number out front. That's what's happening on number 4. That 7 that's out front, it's going to multiply by whatever you find and bring out. So I'm going to ignore the 7 for a minute. I'm not going to forget about it. I need it at the end, but let's just deal with 32. Did y'all figure out what was the biggest perfect square hiding in 32? Yeah, 16 is. 2 goes into 32 16 times, and if you know about perfect squares, you can really stop right there because 16 is a perfect square. Or you could keep going. We can divide by 2 a whole bunch of times here. 32 is just a bunch of 2's. A pair of 2's make a 4. This pair of 2's make a perfect square of 4. So 32 breaks down to 4 times 4 times 2. I usually put those back together to make the biggest perfect square that I can. So 32 breaks apart into 16 times 2. Now let's take the square root of 16, which is what? Okay, so 32 all by itself would be 4 times the square root of 2. But there was already a 7 out there. So what's my final answer going to be? Yeah, you just do 7 times 4 times the square root of 2. So your final answer here is 28 times the square root of 2. Yeah, if there's a number out in front, all you do is hold on to that number and multiply it by whatever you ended up bringing out. So are y'all going to be okay with this on a daily grade? All right.